This video is an attempt to explain where the chain rule comes from and why it's needed. We'll cover two forms for the derivative using chain rule. We use the prime notation if you have a composition function, f composed of u in terms of x, and the second form has the d dx notation for the derivative of a composition function. Let's take a look here at f of x. f of x is a composition function. The inside function is 3x plus 1. You could think of that as your u of x, your u substitution, that is plugged into the square function. Before we get started, I'd like to take a look at the expanded form. If we expand f of x, we would have, if this distributes out, 9x squared plus 6x plus 1. Expanding this is practical here since you only need to use the power rule directly. You don't need to use any chain rule since this is no longer a composition function. If you find f prime of x, we should get 9 times 2, 18, x to the 1 plus 6. So we know our final answer at the end of the day should have a derivative, f prime of x, as 18x plus 6. So let's go back to the composition form. So let's say we try to use the derivative using the power rule, and you want to try to bring the power 2 down. You multiply by 3x plus 1 and bring it to the power of 1. So this answer is actually not quite yet the correct answer we need to get. We need to get 18x plus 6, but if you see distributing the 2, we would get 6x plus 2. So it looks like our answer here is off by a factor of 3. So where does the 3 come from? Let's go back to the inside part, u of x, and chain rule is asking us to multiply by u prime of x. U prime of x, the derivative of this u inside the function, derivative of 3x plus 1 is equal to 3. So if we multiply by this u prime of x, if we multiply by 3 on each step, that's where we are going to see this derivative should become 18x plus 6, which confirms the answer we got at the bottom from power rule. Let's take a look at another composition function. I like this form, the d dx form for the chain rule, since it shows the derivative is df du times du dx, and this du dx is like multiplying by the derivative of the inside part. But I also like how you could see the units of the du. The du's cancel. So this is a reminder that this is equivalent to df dx, the derivative of this f in terms of x. So let's take a look. And if we want to do this derivative, and we want to find the derivative with respect to u, first let me think of this as square root of u. U is equal to sine of x after all. So if we take the derivative of f with respect to u, this first part of this notation here, what we would have is 1/2 times u to the negative 1/2. That's if it's in terms of u. Now this formula is asking us to multiply by du dx. So let's substitute here what the u is. U of x equals sine x. So this form becomes 1/2 times sine x, to make it go back in terms of x, to the negative 1/2, multiplied by du dx. So let's go back to u. If u of x is sine x, the derivative of u with respect to x is equal to cosine x. So what we need to do here is multiply by cosine x. This brings us all in terms of x again. So now we have, if we simplify this, let's rewrite this with cosine x on the numerator divided by 2 square root sine x on the denominator. So there's our derivative of the function, a composite function, in terms of x.